Welcome to the Math 3 lesson summary video for the task Brutus Bites Back. This is a develop understanding task, so as you can see at the top of your screen, the purpose of this task is to develop the concept of inverse functions in a linear context. So we have our friends Carlos and Clarita that we learned about back in Math 1. This time they're still working with their pet sitting business, but they are looking at feeding the dogs that are in their care. And the key piece of information that you'll see at the very bottom of the last sentence is that the Canine Catering Company located in their town sells 7 pounds of food for $5. So we have 7 pounds of food for $5. Carlos chose to represent that with pounds as the independent variable, as you can see on Carlos's x-axis, and dollars as the dependent variable on the y-axis, whereas Clarita chose to use dollars as the independent variable on the x-axis and pounds as the dependent variable on the y-axis. So back in question 2, it asked us to write an equation for each of these graphs. So Carlos would have gotten the equation d equals 5/7 p, and that's because the slope is a rise of 5 and a run of 7 to get to this point, and this is a linear function, and the y-intercept is 0. Clarita, on the other hand, would have gotten the function p equals 7/5 d because her rise was 7 and her run was 5 due to the different way that she represented the situation with dollars on the x-axis and pounds on the y-axis. So those are the equations of both of their graphs. And question 3 asks us to write a question that would most easily be answered by Carlos's graph. And so the questions that could be answered by Carlos's graph are questions of the form: how many dollars will it cost to buy p pounds of dog food? Because the dollars depends on the pounds in Carlos's scenario and the way that he's graphed it. It also asks us to write a question that could be most easily answered by Clarita's graph. And her questions would be of the form: how many pounds of food can be purchased for d dollars? Because in her scenario, the pounds depend on the dollars. So the difference is, in Carlos's case, dollars depends on pounds, and in Clarita's case, pounds depends on dollars. So they represented the same piece of information in different ways. Question 4 asks, what is the relationship between the two functions that we've developed? So again, Carlos's was d equals 5/7 p, and Clarita's was p equals 7/5 d. So if I look at a table of values, you can see Carlos's table of values at 7 pounds of food will cost $5, 14 pounds of food will cost $10, 21 pounds of food will cost $15. And then Clarita, for $0 you can buy 0 pounds of food, obviously. If I move over here, for $10 you can buy 14 pounds of food, and at the end for $20 you can buy 28 pounds of food. So we need to know that an inverse relationship is evident from a table when the x-y points get switched to become yx points. So is that happening from Carlos's table to Clarita's table? And if we look, we can see that it is. For example, here 7,5 became 5,7, and over here 21,15 became 15,21. And you can look at all the other points that are lined up in columns and see that xy is becoming yx. So these are inverse functions. So in function notation, we would say that d of p, Carlos's function, is equal to p inverse. And p of d, Clarita's function, is equal to d inverse. And that's this to the -1 power here that you see in both of these means inverse. So as we continue to question 6 and 7, we see that the scenario changes. Online, Carlos found a company that will sell 8 pounds of Brutus Bites for $6, plus a flat $5 shipping charge for each order. So that $5 shipping charge for each order is what makes this scenario a little bit more complicated, because each of the linear functions you're going to develop, one using Carlos's approach in problem 6 and the other using Clarita's approach in problem 7, will have y-intercepts. So that makes it a little more difficult. I'm going to allow you to do this on your own. Instead of going over this, I would like to go over a different example. So here's an example of a linear function that has a y-intercept that's not 0. the green graph, f of x equals 3/4 x minus 2. And its inverse, f inverse of x equals 4/3 times x plus 2. And I want to make a couple of observations about inverses, and I want you to see if you notice these same things for the two functions that you develop in problems 6 and 7. So number one, these function rules are opposite operations in the reverse order. So for f of x, we have 3/4 times x minus 2. So the two operations are first multiplying by 3/4 and second subtracting by 2. So the inverse of that would be to add and then divide. Well, hold on a second, you might say. This inverse function doesn't look like it's adding and dividing. Well, remember, I could rewrite that inverse function as x plus 2 divided by 3/4. And that makes it much more clear that we are adding and then dividing, opposite operations in the reverse order. So we went from first multiplying and then subtracting to, in the inverse, adding and then dividing. So not only are the operations opposite, but the order is being reversed. And dividing by a fraction is the same as multiplying by the reciprocal. So that's why I have times 4/3, because dividing by 3/4 is the same as multiplying by 4/3. So this is just a more elegant way of writing that function. But this representation makes it more clear that they're opposite operations in the reverse order. Number two, the x and y values from the table are flipped. xy becomes yx, and we already saw that earlier in problem 4. And that's true here as well. 4, 8 becomes 8, 4. Negative 16, negative 14 becomes negative 14, negative 16. And if you think back to Math 2, a rule like this for a transformation, xy becomes yx, that was the rule that we used back in Math 2 for a reflection over the line y equals x. So you can see that the blue line and the green line are reflections of each other over the line y equals x. So these three things will always be true about inverse functions, whether they're linear functions or not. So in the rest of the unit, we're going to look at other types of functions and their inverses. Thank you for watching. Make sure you finish the task, and if you need help with the Ready, Set, Go problems, be sure to check your Canvas site for your course and the Ready, Set, Go support problems there.